In section 4.5, we're going to talk about polynomial functions. Let's start with degree 2 functions. They will have a standard form of y equal ax squared plus bx plus c. When we graph them, they are parabolas. When a is positive or greater than 0, the parabola will have arrows pointing up, and the parabola will have a minimum value, or the lowest part of the value. That's also known as the vertex. When a is greater than 0, that's how the parabola looks. When a is less than 0 or negative, then the parabola has arrows pointing down and it has a highest value. And at that highest value, we will have an ordered pair that is also the vertex. With a quadratic function, a cannot be equal to 0. We state that in the definition. A is not equal to 0 because if it were equal to 0, then we would simply have 0x squared, which is 0, and it sort of dissolves down to simply bx plus c, which is a linear function. It's no longer a degree 2 function. Once we graph the parabola in the calculator, finding the vertex is sometimes just a very easy visual thing to do and find what ordered pair that might be. Let's say this parabola has a vertex of 4, negative 2. That's its lowest point on the graph. When using your free graph calc to find the vertex, you can double tap the screen and click on Find Minima or Maxima. It'll be a minima if it's got a valley. It'll be a maxima if it has a mountaintop. Through the vertex is a vertical line that is called the axis of symmetry. If we drew a vertical line through the vertex, we would see that the parabola mirrors itself. It's symmetrical. The left side matches the right side if we could fold that graph in half like a piece of paper. The axis of symmetry has an equation. The equation is x is equal to 4 in this case. A vertical line has an equation. X is equal to whatever value of x that vertical line is going through. If your parabola points down and has a maxima, again, you can use the free graph calc feature by double tapping the graph and choose Find Minima or Maxima. If the parabola has a vertex, for instance, of 0, 5, the axis of symmetry is a vertical line going through 0, 5, and the equation would be x is equal to 0. There's also an equation for finding the axis of symmetry. If you aren't able to graph it, you can use the equation x is equal to the opposite of b over 2a. Let's use the formula x is equal to the opposite of b over 2a to find the axis of symmetry for this particular quadratic formula. In this formula, it's in standard form, ax squared plus bx plus c. So a is negative 1, b is negative 2. Using our formula, we would fill those in. X is equal to, the opposite of b would be positive 2, and 2 times negative 1 would be the denominator 2a. So that would simplify to 2 over negative 2. X is equal to negative 1. That is your axis of symmetry. Okay, let's use y equal x squared plus 4x plus 3 to talk about the vertex, the axis of symmetry, and then the third thing we want to do is find roots and zeros. The vertex of this particular parabola is its lowest point right here. That point is negative 2, negative 1. The axis of symmetry would be x is equal to negative 2. If we drew a vertical line through the vertex, it would go right here where x is equal to negative 2. I've listed 4 ways for finding roots and zeros. Some of them work better than others. It depends on the quadratic function. You can always, after you graph the function, double tap the screen on the graph and use find roots. It then supplies you with a vertical line that you can move around, and your goal is to find out where the graph is crossing the x-axis. The second way is to factor whenever possible. Third way is use the quadratic formula when factoring doesn't work. And the fourth way is to check where the graph crosses the x-axis. So the fourth way is you're looking where the graph crosses the x-axis. And in this particular one, we have 2 places. It's crossing the x-axis at negative 3 and at negative 1. Those are our roots and zeros. Factoring works nicely with this one as well. We've done some of this in previous chapters. We take this equation, y is equal to x squared plus 4x plus 3. Instead of having it equal to y, we set it equal to 0 because the x-axis is where y is equal to 0. This is where y is equal to 0. So we change y to 0 and we factor x squared plus 4x plus 3 into x plus 3, x plus 1. And then we set each factor equal to 0. Since the whole thing is equal to 0, when we multiply the factors, that means each factor can be set equal to 0. So we get x is equal to negative 3 and x is equal to negative 1, which is what we noticed earlier when we noticed where the graph is crossing the x-axis. The other way would be to use the quadratic formula, remembering it's in the standard form ax squared plus bx plus c. So a is 1, b is 4, c is 3, and we use our quadratic formula. X is equal to the opposite of b plus or minus the square root of b squared minus 4 times a times c, and then all of that is divided by 2 times a. Keep simplifying. X is equal to negative 4 plus or minus the square root of 16 minus 12, all divided by 2. X is equal to negative 4 plus or minus the square root of 4 divided by 2. Keep simplifying. Negative 4 plus or minus 2 divided by 2. And now at this point we look at it as negative 4 plus 2 divided by 2, which would be negative 2 divided by 2, or negative 1, or negative 4 minus 2 divided by 2, which would be negative 6 divided by 2, which is negative 3. We get the same zeros no matter how we do this. What if when we graph the quadratic function, it doesn't cross the x-axis at an integer? It's going to have a decimal for an answer that is one of its roots and zeros. In other words, it's not crossing right on positive 1, it's crossing between positive 1 and positive 2. It's not crossing right at negative 5, it's crossing somewhere between negative 5 and negative 6. And we also notice that this particular quadratic won't factor. There's no way to factor it. We would have to use the quadratic formula to figure this out. The quadratic formula is going to give us an answer that has a radical in it, and the calculator is going to give us an answer that has a decimal in it. Let's see what we find. When we use the quadratic, we end up with negative 2 plus or minus 2 radical 3. That is not what the calculator will give you. The calculator will give you the decimal values that are equivalent to negative 2 plus or minus 2 radical 3. If you use the double tap feature on your free GraphCalc and ask it to find the roots of this quadratic, it will give you values of 1.4641, which is equal to negative 2 plus 2 square root of 3, and it will give you negative 5.4641, which is equal to negative 2 minus 2 square root of 3. A degree 3 polynomial has an exponent of 3, and you've done a little bit of factoring with degree 3 polynomials when we've done factoring by grouping in an earlier chapter. Now I want to focus on simply finding the zeros of a degree 3 polynomial. A degree 3 polynomial will have 3 zeros. Because the highest exponent is a 3, it will have 3 zeros every time. Finding them can be done using the graph. The free GraphCalc will take you to them as well. You sometimes might be able to factor by grouping, sometimes not. There is no formula like a quadratic formula for a degree 3 that's user-friendly. So we're going to stick with determining the zeros of the degree 3 polynomials using our graph. We're going to double tap, ask it to find the roots, and we're going to use the decimal values that it gives us. So let's do one as a quick example. This equation is y is equal to x cubed minus 2x squared plus x, and I've already graphed it for you. It's touching the x-axis in two places, here at x equal 1 and here at x equals 0. I've also taken a piece of the table that was provided in the graphing calculator. When x is equal to 0, y is equal to 0, and when x is equal to 1, y is equal to 0. X is equal to 0 means y is equal to 0, and x is equal to 1 means y is equal to 0. That's why these are called zeros in the first place. The zeros of an equation are where y is equal to 0, where y is equal to 0, and that's on the x-axis. So you might be wondering, if a degree 3 polynomial has 3 zeros and we found two of them. Here they are, x is equal to 0 and x is equal to 1 are two of those. Where's the third one? It's not crossing the x-axis anywhere else. Well, the answer is that one of these zeros, x is equal to 1 or x is equal to 0, occurs twice. If we were to factor this degree 3 polynomial, one of these would have a multiplicity or an occurrence. It would occur twice. We would factor out an x and get x times x squared minus 2x plus 1. We would continue factoring that. It would equal x times x minus 1, x minus 1. And if we set each of those factors equal to 0, we get x is equal to 0, x is equal to 1, and x is equal to 1 again. This is called a multiplicity of 2. It's a double root. Multiplicity 2 means it occurs twice.